Good morning. We will continue our SolidWorks lesson. Last time I asked you to try this at home. So, did you try this? Any questions about this drawing? So, when I discuss this one, I ask you to draw this part only and up to here and use the arc tool and offset tools. So, I will do it for you and show you how it works. So, if you carefully look at this drawing, origin is here. And this horizontal center line is aligning with the origin. So we can start from here and do it. Rather than starting from here, we can start from here and try to complete the lines as much as possible. So I will do that. Later we can put the relations and dimensions. There are 4, 1, 2, 3. Now we can start putting the relations or dimensions. If you carefully look at this area, all these are equal in length. So I can make them equal. So I will do that now. So if you carefully select all these things like this, it can be done easily. So I can select from a box selection like this, and it will select all these lines and I can make it equal. So that is going to be easy. Otherwise, if you want to select everything one by one, it takes a lot of time. So this left to right selection will help you to do that. But don't do right to left selection. If you do right to left selection, these lines also will be selected. So I want only these lines to be selected, including this vertical line. So we can just select like this and make them equal easily. So there's a equal symbol here, equal dimension. That's how it can be done easily or faster. And here the origin is there, and our line is almost aligned to this origin. Then then we can put the dimensions here. Say this is 5. So this is going to be 5. Then all the lines will be adjusted. Then from here to the this is 30. Now you can see some lines got so I will not put it now until I adjust the other things. So this is going to be 10. And this talking about these horizontal dimensions, this is the innermost one is 86. So from here to here, it's going to be 86. So I ask you to take the mouse to this side. So it will be double 86. So when you do that, you can see how the others are changing. So I will not put it now. Uh, then this is going to be 100 inner one. We will not put, if something is going to distract our drawing, we will not put those dimensions at the moment. Then the outermost one is 116, that is this one. We will not put it now. So I will put 106, you can see whether it's going to work. So now it's quite okay, 116 is taken. Then we will adjust the other ones gradually. So this is coming from the experience, and you need to understand how SolidWorks works. 100, this is 26, and this is going to be 106. So I don't need to put 106, it's automatically coming, so we can have a driven image. So that's how I change the dimensions. So it's 116 to the outer surface here. Then we have 100 to the inside here. Then 86 here. So all these things are given. 106 is also given, but I don't need to put it. Already my dimension is over defined. Is defined. So that's all I can put at the moment. So I put all these 4 dimensions horizontal, and 30 I gave, 5 gave, 10 gave. So now we have to move on to the arcs. So we have to draw an arc starting from this point to this point. So these are the obvious things. This I don't know the dimension here, so we can start from here to here. And from the bottom, it's 110 to this topmost point. So we will just draw a 3-point arc. I don't know the center, I don't know. So I will just click here somewhere and click here. And I'll just draw a normal one. Later we can put the dimensions. So this is going to be 170. And this topmost point from the origin is, it's 110. Then 110 given, this is given, so that's it. So we will get this here, and the center should be aligned with this line, so we can have a coincident relationship clicking on the center point and this line, and it's coincident. So now this is in a single line. So that's how I took this arc shape here. So I gave this point 110. This is obviously coming from the lines, and 170 given, and this line and this point should be coincident with each other. So it's coincident. Then we can offset this line by arc by 7 units. So I will offset that one by 7. This one. So I don't need to offset everything. I need only a line, only that arc. So I reverse it, and the distance is 7. Then we can complete this one from here to here, and we can ask extend tool to work now. Extend up to here. Then we can ask trim tool to work and trim this. So if you do it correctly,
Excuse me, sir. Sir, how you offset that line? Can you show me again, please?
This arc.
Yeah.
So we have to use the offset tool here, give the value 7, select this line. So it will be coming in this side direction or that direction. And I don't need the chain. If you select the chain, all these things will be offsetted. I don't need that. So I need only offset with some dimension. Uh, you can select the direction from these tools. I don't need these things. So here I need only this one I need at dimensions in my drawing. Then that's okay. So then we can close this, and now this line I have to extend. So we will extend this line. Then this is extra, so I can use a trim tool and trim it. Then I have to adjust this dimension also. This is 30. I think now it's okay. So all the dimensions given, it's fully defined. A lot of relations are shown. Don't delete these things. It should be there. 110, 86, 116, 100. So all the things I give, I think it's okay. So if we have done it correctly, we should be able to revolve it. So I will apply revolve tool. Center line is automatically taken, and if the sketch is closed, automatically the revolve tool will work. If there is a tiny hole in these sketches, it won't work. So please make sure it's fully closed. That's okay. These are the outcome. So when I dimension this drawing, I didn't put diameter 100. I just put 100 here. But when you take a manufacturing drawing, you need to put diameter 100. This is only for this sketch is only for the SolidWorks. This is not these dimensions are not for production drawings. So diameter is automatically put by the software. So I didn't put it manually. So he has done it for me. So this is the whole idea. I hope you understood why I put 186, 106, 116 without giving 50, without giving 43, without giving 53, without giving 58. Why should we did this way? So when someone read the drawing here, he can understand this is a circular shape and it has a diameter. So that's all. That's why we gave this way the dimensions without giving half values. So this is a section. So we gave a sectional drawing. This is enough for the manufacturing. Uh, so any problems with this model? You can try. I give you some time. Just try it if you haven't done it. I ask you to try this also. You can try these things. I give you 5 minutes. Chapter 5 lecture note is given to Ms. Chaturika. You can, I think you have got it. 5 and 6 I gave to Ms. Chaturika. So these are the two sketches we ask you to try at home. this left side. Better you draw half. That is, forget about this side. You try to draw this shape up to here. Last time also I showed you up to here only. Just draw. Then get a mirror. Take a mirror. That is the easiest way. Uh, there's a center line here and another center line, so you can apply parallelism here to these lines, and for these lines also we can apply parallelism, and try to get a fully defined sketch. So these are double values, all the diameters. uh, you can try this. Then any questions, tell me. I will try to support. And this is a thin revolve, that is inside is hollow. So when you apply the revolve,
Sorry. Hello, sir.
yes,
So that 40, 108, and this is the diameters, right? Not the radius.
no, diameter. So you have to take the mouse to this side, like this way. This same concept. You have to take the mouse to the
Okay.
downside view. Then it will be down.
Okay, this part. Okay, okay.
Uh, and when you apply the 3D tool, revolve tool, you have to apply the thin revolve. That is, I will show it. So here this is a solid revolve. That is, inside is hollow, but we have given the thickness. Now in this drawing we have given the thickness, so automatically the thickness is coming for the drawing. But in this one, thickness is not given. So if you just revolve it, it will be solid in these areas. If you just normally revolve it, there will be material in these areas. So we have to avoid that. So when you apply the revolve tool, if I try to show it from this drawing, in revolve we find a tool called thin features. So thin features will help you to give a thickness for your drawing. So I can apply say 1 millimeter thickness. But in this drawing you can see it's not working because this revolve, this line intersects with the center line here. So when you have this original drawing intersect with the center line, your thin revolve will not work. But if you look at this drawing, the center line is going here, and this is your normal line. So those two lines are not intersecting with each other, so you can give a thickness. Here we can't give thickness because this center line and the normal line overlaps. So that's why in this drawing I can't apply the thin feature. So if you take this line somewhere here, we can apply the thin feature. So that's the thing to remember. So that is the warning I'm getting here. Contour intersects the center line. So these contour lines intersect the center line. So we cannot apply a thickness. That's why 7 millimeter thickness is given in the drawing note, and we are using the solid revolve. So in the solid revolve, it's working. So, but not in the normal one. So please remember that concept. For the thin revolve, we should not intersect the center line and the normal contour lines. It won't work. So so in this drawing, there is no problem. Contour line is here, center line is here. So you can easily apply a thickness to the drawing, and inside will be hollow. So we can apply a 10 millimeter thickness to the drawing. So there will be no material inside. Otherwise, there will be full of material here if you apply a solid revolve. So just do it and see any questions. Let me know. I will also have a simple sketch for this and show you how thin revolve works. So we have a problem like this. I'm just drawing a rough sketch. This kind of our problem. So center line is origin is here. So this is the normal line. So I ask you to apply a parallelism to these lines. So you have parallel conditions. So we can select this line and apply parallel. And so you can see it's going here and there because there are less constraints. So we can ask these to be in a certain horizontal line, then it won't go here and there. So this is parallel, and this is going to be parallel. Then this is then I can apply a mirror. So this is just a rough drawing. So we'll select all these things. Mirror above this one. Mirror. So this is a drawing I did roughly. It is the axis. Then we can go here and apply revolve. So when you apply the revolve, center line is not. There are two center lines, so you have to select the center line. So this will be my drawing. And if I just say 270 degrees, it will be a solid revolve. You can see the material is there. And if you apply a thin revolve, you can give say 2 millimeter thickness. So you can see inside is solid. So thin can be adjusted uh, in both directions. So you can have a mid plane, that is you can measure 2 millimeters, one here, one there. Or else you can have two directions, that is one side is 2 millimeters, the other side is 10 millimeters. So here this side is 2 millimeters, this side is 10 millimeters. So you can have two values also, or a single value, or a symmetrical mid plane value. So this way we can get a hollow model. So it's not a solid model, it's just a normal, it has a normal thickness. So this is similar to the drawing we are doing here. So I hope you understand how revolve thin works. Now it says revolve thin, and you cannot take it back to solid revolve again. So this button is not working. So if you want to get a solid revolve, you have to delete this. Delete this and do a solid revolve again. So this will be my center line. Now it's a solid revolve. Don't take this 270 degrees. Now it's a solid revolve. You can see it's not a thin revolve. And if you go to edit features, this thin button is not shown again. So you cannot make it a thin revolve. So if you want to make it thin revolve, you have to delete this from the beginning. Delete everything and start from the beginning again and apply a thin revolve. So this is the center. So I hope you understood. If you go with the revolve, solid revolves, you cannot change it to thin revolve. You have to delete the entire thing and do it again. And when you do the revolving, you have to make sure these lines don't come and hit you. So if you just come do this kind of editing, just come in and say overlapping with the center line. So I can overlap it easily by using coincidence. Say collinear. Now they are overlapping. Now when I try to apply a revolve, center line is this. Solid is working, but thin revolve will not work. Resultant contours intersect the center line, so there is a problem. So when you apply thin revolve, be careful not to intersect the contour lines with the center. I hope you understand. So just
So
work.
can you explain again?
That is you can understand this warning message. The resultant contour intersect the center line. So this center line is here. This is my normal line. If you overlap the center line with the normal line, you cannot get the revolve tool working. Thin revolve. But solid revolve will work. Thin revolve will not work. Because you have to have a thickness, small thickness inside. So if you intersect the center line and the normal line, it will not generate the 3D. Because you have to have a hollow inside here. So if you this way we can achieve. Say I'll undo this. Now I can apply thin revolve, no problem. So because I have a freedom here to make a hole. If you take this one here and overlap with the center line, I don't have freedom to make a hollow inside. That's the problem. So you think a little bit why it's not working. So now I can get a hollow shape. If I come and hit it with this one, I cannot generate a thickness here. So now thin revolve will work. But when I come and hit this line with this line, where should I get the thickness? I cannot get a thickness. So that's the problem. That's why it's not working for thin features. මේ දෙක overlap වුණාම මෙතන අපිට thickness එකක් තියන්න බෑ. Simple. So I hope you understood. So that's the logic behind this thing too. So remember with that thing about the thin revolve. Any questions about this? Probably you may have questions about taking this shape. So apply the parallelism, this line, this line, this line, this line, and apply the collinearity here. This line should be collinear with this line. So you can apply collinearity to maintain the same height. And 65 give 65, then 62 this side, 62 this side also should be given. You should get a fully defined sketch. Just try it and see. You will try this question also. Don't worry about the 3D shape at the moment. 3D shape has some fillet tools and chamfers applied. So I haven't taught you those things still. Here we have the fillets here, and there's a small special shape here. This is called a slot tool. So how can we do slot tools? We will discuss. So if I get a drawing like this, where can I start? So easiest way to start is from the lines. So don't worry about these arc shapes, these circular shapes. So we will start from the basic line. So if you just look at our slides, they have started with the slot, but I personally don't like to start with the slot. So you can just draw these kind of lines and complete the drawing quickly. So I will have a start now. So here we don't need to draw both the sides. We can make a symmetric drawing, apply the mirror. So we can start from here, and without drawing this one also we can go up to here. So I will just do it and show you. First few days I am doing these tutorials with you to make sure you understand the concept. So it's up to you to master these things by doing exercises. if I can take the origin here, it's mentioned here, the center of the circle. So for the time being, we will not worry about that so much. Anyway, I will draw center lines. So if you want to start the line tool, we don't need to go here and start it by, it's taking time to go here. So you can just press the letter L and start. So I just press the letter L, and we can, if you want to get center lines, just click on this one and do it. So remember the letter L, capital L or simple L. We'll start the line tool. So I started the line tool, and you can have a construction line. Infinite line is it's going infinitely. It's going to the, it cannot we cannot get a corner. So it's going infinite. And midpoint line also, we discussed what is midpoint line. Midpoint line is it helps us to get the symmetrical line. So I hope you remember this concept. Now we will start the drawing. I will start from here. We'll keep this in mind. So I'm just drawing up to here. I didn't worry about this circle. Later we can draw this. So this is all I can do from line tool. So if I want, I can get a mirror. So I will get a mirror these lines. This is not the only way, but this may be the fastest way. So I got the mirror. Then I don't need to apply symmetricity. Already symmetricity is applied. Now we can adjust these dimensions. So from here to here, it's going to be, I am not worrying about the slot and the other things. We try to adjust the lines as much as possible. Then this is 30. Then this angle is 28. Then this angle is 75. Then we can go to these dimensions. 49. Then this is 61. So and this gap is 20. So don't worry about these font sizes, the arrow sizes. Those are not a worry at the moment, because we don't produce a manufacturing drawing from this. This is only for the 3D model. So so all the dimensions given this side. Okay. So now we can concentrate on these other areas. So this is a circular shape. We can draw that. This is radius 19. This is diameter 30. Because this is an arc shape, they have given radius. But I will draw circles because it's easy. So this we will draw two circles and dimension here. So this is going to be 38 diameter, and this is 13 diameter. Now if I want, I can use the trim tools and trim the unnecessary things. So that's finished. Then we can move on to the other area. So this one, if I try to use the arcs, we can draw arcs. So we can draw an arc here, another arc here, and draw these small arcs and get it from this arc tool. But takes some time to use the arcs. So there's a tool called slot tool in SolidWorks. So we have four shapes basically. First one is a straight slot. I will quickly go through these things before I come to the tutorial. So I will save this file. Uh, Now I'll come back to this one. Straight slot is you have four shapes here. You just give the two corners like this and make a slot shape like this. So this is called a straight slot. And there's another one called center point straight slot. That is you give a center point and a corner, and the other side will be mirrored. And this is another one. And this is called 3-point arc slot. This is coming from the 3-point arc, and similar to this one, 3-point arc. So we have to give 3 points and draw. Sorry, we have to give 3 points and third point given, then it's generated and slot. So this can be used here, but this last one will be the easiest. Center point arc. So that is, you just draw a center point arc this way and make it a slot. So these two are similar to the tools available here: center point arc, 3-point arc. So center point slot, 3-point slot. So we can use this one, the last one here, because I know the center here. Center is here. Quickly we can draw it. So we will just do it and see. So here we need to use the center point arc slot. That is the easiest center norms. This is the center. Then I don't know the starting exactly. You just draw it roughly like this. Just draw a rough sketch and just draw a rough sketch of this. Now roughly I do. And the center point of the slot should be aligned with the horizontal center. So we can click here and click on this one and make it coincide. Then it's aligning nicely. Then you can see now it's symmetric because I aligned it. I align the center point with the horizontal line. Now it's symmetrical automatically. So I don't need to worry about that. Symmetricity so much. Then we can apply these radiuses 82, 69, 56. So we will apply that. This should be 82. This should be 69. And this should be 56. It's automatically coming because the thickness is defined. So I don't need to give it, I just put it as a given dimension. And now this angle of the slot is 60 degrees. So how can I give an angle? So I think we cannot just click on this and get it. So we can just click on this point and the center point and give the angle. So I will do it again. Click on this point and the center point, and angle can be defined. So angle is 60. So I have already defined the arc slot. So this is already done, and this can be later trimmed. So don't worry about these things. Now we can extend these lines up to here. I'll use the extend tool and these should be removed. Trim. So when I apply the trim, there will be messages coming. So I need to remove that area. So I will do that. Trim. You can use the process trim. Last one is easier. This warning will come because I am removing the slot shape now. That's why there's a warning. So this is how it works, and we can draw circles now. This is 15 diameter here. Smart dimensions. If you want, you can make a mirror of this circle. Mirror this circle about this circle. Now it's almost finished. And this is now having blue colors because I removed this part of the slot. So we need to give this radius 13. Now it's black, becoming black. This side also 30. Still it's blue. All the lines getting black here, but some points are still blue. These points are still blue. So probably this is, we have to apply the tangent relations. So here we should have tangent relation. Now it's becoming black. Here also we should apply tangent because I deleted that part of the slot. These problems coming. These are tangent. Now it's overdefined, so I don't need to give there. Fix this. Still there are some blue. These are we didn't fix these points last day, but if they are giving trouble, you can make them fix. Still blue. So I have issue with these blue areas. Still blue. So you can try this and see. And if you have done it correctly, I should be able to make a 3D sketch. I will show you how to make it fully defined in a while. Now, if I have done it correctly, I should be able to draw a 3D part. So 3D part is generating. Otherwise, if there is a tiny hole, you cannot get it. So you can see this drawing is entirely different from this one. This is after we apply the chamfers fillets, and I have applied some 3D operations. So this is the basic extrusion. So we haven't done these things still, how to get the 3D shapes, 3D pillars, 3D chamfers. So for the time being, you should be able to do this exercise. Just do it and see any questions. Let me know. If I carefully monitor this drawing, we can find some fillets here. So these are round corners. So they have made these sharp corners round a little bit. So I have to make them round. So these sharp corners should be made filleted. So I hope you know the word fillets. So what we can do is, say, I just show an image. So it's in chapter 3. So we have to discuss about the fillet tool a little bit to apply these fillets in these sharp corners. So I will just show you the theory a little bit. So this we have to apply this fillet tool. So the idea of fillet tool is to make these sharp corners round corners. So you can have lines connected to each other like L shape, or you can have these kind of, it's also non-intersecting lines, and apply the fillets. So the chamfer is idea is to get something like this shape. So chamfer drawings are drawings like this shape. So we can give two distances like D1 and D1. D1 can be same, or D1 and D2. So these distances can be changed, or this distance can be same, or you can give a distance and angle and get this chamfer shape. So we will look at how to apply the fillets for this drawing. So I hope you have discussed these things in manual classes. So I need to apply a fillet here. Radius is given as 5, so everywhere it's 5. So we will take the sketch and go to fillet tools here. So we have fillets here and chamfers. So I have to apply fillets. Radius is 5, and we have to dimension the fillets, then it's easy for us. Then we'll just click on these corners and press OK. So everywhere the software has put the dimensions for me now, it's easy for me, and all these corners are becoming filleted corners. So it's really easy, you just need to select the corner, automatically it will work. So I applied the fillet here, 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 and here. To avoid these stresses, we have to reduce the stresses in these sharp corners, so we can apply fillets and do it. Then I have an issue here with the fully defining sketches. If I just look at my drawing, all the things are almost black, but still I am getting underdefined message in the bottom. So how can I make it fully defined? So I have done a lot of relations, I have given a lot of dimensions, still I couldn't figure it out what went wrong. But the 3D model is coming, so 3D model is generating, but it's not fully defined. So there is a automatic tool available in the software to make it fully defined. So if you cannot figure it out by yourself, just come here under display delete relations. There's a tool called fully defined sketches. But do this at the last. So if you cannot do it by yourself, apply this tool, because software will put the relations and dimensions unnecessary things sometimes. So we will try to make it automatically fully defined. And here we can select all entities in the sketch or selected entities. So if you find some areas blue, you select those things. Now here I cannot find any areas in blue. In my drawing, all the things are black. So if you can find some areas, you just select those lines and press the calculate button. He will do it. And in under relations, he will try to put all these relations by himself, software by himself. And dimensions also, he will try to put a lot of dimensions by himself. So be careful when you do this automatic tool. Use this automatic. This is for the last mode. This is like a trump card. So don't put the trump card from the beginning. At the beginning, do it at the end if you cannot do it by yourself. Otherwise, software will put lot of relation dimensions which may not be necessary. So I will just select all entities here and try to do a calculation. Sometimes this will work, sometimes this may not work. So here I have problems, no solution found. So he is trying to do it for me, but he's generating some errors. So is the problem. No solution found. So I am in a bit of a worry now because the software cannot also do it for me. Mm, So I will try to use my head and try to do it by myself. So this should be tangent. Now it says no solution found. So when I put the tangent here, there is a problem. So you can also look at your drawing and try to make it fully defined. Problem here is with the slot here. So you can see that when I put the tangent here, it's getting overdefined. So problem is with the slot shape. So I have a bit of a worry. All the lines are black, still it's underdefined. So this automatic tool is also not helping me. So you can try this one also and check whether he can do it for you. I will just select this one. It's going to be overdefined. So my problem is problem lying here, somewhere here. Other things are quite okay. So if you cannot make it fully defined, and if you are pretty sure that all the lines are black, now it's okay. Just go to the next operation and make it 3D. So don't hang on this area too much if you cannot figure it out. Underdefined drawings also you can make it 3D, no problem. So I will not hang on this one because we don't have much time. So we will make it a 3D design. So this is my basic shape. You can try this. Any questions, let me know. So we have discussed the slot tool and the filler tool in this drawing. We discussed the filler tool. Then chamfer tool also, it's not difficult. I will just show you the chamfer tool quickly. So if you have questions, just try these things and let me know any questions we will discuss. So talking about the chamfer tool, say if I have something like this. Now fillet is easy, just select the fillet and give a radius say 5, 10 here. Dimension and keep constraint corners, that is you have to keep the vertical and horizontal constraints. It's okay, it will be fillet. So this is called fillets. You can do it for multiple edges, multiple corners. And if you talk about the chamfer tool, we have two methods. One is distance, and it says equal distance. Now you are getting the result like this. But if you say unequal distances, something like this, First line is this, second line is this. So this is the chamfer shape. So I will undo this and show you again. Two distances are selected. First distance is 10 here, second distance is 12. So when you select this as the first one, this will be 10, second one, this will be 12. Or else you can have equal distances. So equal distances, click here, click here. Or else you can apply angle distance. That is 10 degrees from this corner, 10 millimeters, and 45 measured from here. So it will first measure 10 from here and 45 from there. So if you want, you can have something like if you say this way 10 here, measurement happen this way 10 and 45 this way. So it's important to select the first line. Otherwise, you will get wrong results. So this is how chamfer tool works. And now to talk about the other tools available here, we have easy ones. So we have discussed mirror, offset. We didn't discuss this one. And I discussed this fully defined tool. Add relation, delete relations. We can delete by pressing the delete key, or else use this one also. Add relations also, we can just select the lines and automatically this add relation tool will work. So I didn't discuss these tools heavily. These are the obvious things. And I'll discuss this new tool here. So what do you mean by these tools? I will just try to create a rectangle here. Now, if I want to drag this is called stretching. So you can see the lines are stretched here. And then there's another tool called move. Move entities. Now, if you select this line and ask the software to move it, say from 2, say OXY. From 2 means from this point to another point, say OXY. XY is you can move it in X and Y direction, but it didn't move, this point didn't move. So I will select the entire rectangle, and if I just apply this one, you can see it's moving. So the rectangle is moved. Or else if I just clear this and select this one and try to move it, you can see it's moving. So it's but it didn't break because it had a relation here. So move tool, these tools are not really very important, but heavily used tools. So move tool will helps you to move the things here and there. Say I can just select this rectangle. Say I want to put the rectangle corner, this corner here. So we cannot just put it like this, it will distort the shape. So we can select the entire rectangle like this and use the move tool here and select this as the point to move. Starting point, and can put it here like this. So we are using the from to method. So I selected that point and put it there. So I will do it again. Suppose I want to put this rectangle here or circle here. So you select this circle and go to move tool. Use the from to method from to here. So and to here. So you can move it like this. So if you want to get a copy of this circle here and here, so what we can do is we select the circle, move and copy are almost same. Copy from to here to here. So we can get lot of copies. So move is just a full movement here. We don't get copies in move, but in copy tool we can keep the original here and get the copies to the desired places. So move and copy are almost similar tools. Then we have the rotate tool. So rotate tool, the idea is if you want to rotate this rectangle by 45 degrees, we can do it. Say I'll just use the rotate tool here, select all these lines here, and center of rotation, say here. Now what happens is it rotate around the center. So I can increase the angle. You can see it's rotating. And if you want, you can keep these relations. Say this there may be 90-degree relation. So keep those things while rotating. Or else just violate those relations. So this is the outcome. So this may be important when you want to edit your drawing. So if you find this is not the correct orientation, and if I want to rotate this, don't draw it again. Use these tools and rotate. Say if I rotate from here, it will be rotated this. So we can quickly give a value and rotate. I hope you understood these are not difficult tools. Then we have the scale tool. Say if I want to scale it twice, say scale about this point, and you can see I scale it twice. And if you want to get a copy, you have the scale up version and the normal version also. So that. So these may be useful when you do designs or when you want to edit your design. So select these things, go to scale, and if you select somewhere here, scaling happens about this point. So I can apply a scale factor, so you can see how it works. And if you want, you can have multiple scales like this, because this copy tool is working. Otherwise, you cannot have multiple scales. So I gave the scale factor twice the original size, and I need 3 copies. 1, 2. So I hope you understood. So this is coming as a result. Now if I get this kind of a result, and if you want to get something like extrusion shape from here, so you have several contours in this probe. I have this contour, another one, lot of contours in a single draw. So if I try to apply the extrusion tool for this one, so obtain a bit of bother what to extrude. Now you can see automatically the selected contour tool is going to work here. Because I have a lot of contours, he doesn't know where to start, what to extrude. So you can use the selected contour method and select a contour you want to extrude like this. But if you select this contour also, it's same height. So if I want, I can have different heights like a staircase from this draw. So I selected this as the first contour and press OK, 10 millimeters. Now when I press OK here, what happens? The original sketch vanishes. Now if I want to extrude the other sketches, you have to come here and click on the sketch and use the extrusion tool again and select the other contour. Then we can select this as 20 millimeters. Done. So you can see from a single sketch, I am drawing different extrusion. So this shares the same sketch. You can select the sketch, go to extrusion. This is called contour selection method. So I will clear this contour and select the next contour. So next contour can be say 30 millimeters. So you can see from a single sketch how I am developing my model. So click on the sketch and go to extrude again, and this is not the correct contour, this is the contour I want. So if I want, I can make it reverse and develop something like this. So I just started from a normal sketch. So my sketch is just this one. I have several loops, several contours, and I ended up with something like this using the extrusion method only. So I didn't sketch again and again and again. So if you want to do it, sometimes we may sketch this shape and this shape and this shape. Lot of unnecessary work we are doing. So that will be removed from these kind of easy methods. So I will just do it again and show you how it works. So if I want to model a staircase, the easiest ways are what? So we will just use this. This may be our first step, and this may be our second step. I will just draw normal lines. If you want, you can copy or offset the lines and get it. This is our third step. So I have a lot of lines, contours. Now when I apply the extrusion, I have to select the correct contour. This is say 10 millimeters. Okay. Now this sketch vanishes. Disappears hidden. You can just click on this and make it visible and go to extrude the and select this and give a different height. And again vanishes. Just click on this. Repeat the same process. Select this and give another. So easily, without drawing three sketches separately, we can do it from a single sketch. So everyone will share this sketch 2, sketch 2, sketch 2. So I hope you understood. So this is called the contour selection methods. So when you get a drawing, you can think whether I can use this method without drawing several times the sketches, 2D sketches. From a single sketch, can I do it? Can I obtain a 3D model? So I hope you understood about this concept. So I did only a single loop, several loops in a single sketch. You can try this and see. Any questions, let me know. So yeah, I hope you understood this. So we have one more tool to discuss there, that is called stretching. So that's also we are not doing using heavily. So the tool here under moves called stretching. Also we are not using heavily. So we have this stretching tool here. So stretching can be done manually also, as I showed you. So we can just drag it like this, and this is called stretching. So manually also we can do it. Always use the software tools. Click on this and say XY. You see it's not working. So you just select all these things. It's like moving. So stretching is somewhat different in different softwares will work in different ways. So if you apply stretching to these three lines, you can see how it works. So stretching is not going to work only for this line. So if you try to apply this line, it won't work. Uh, if you want to stretch this line, you have to select the neighbor source like this. and give a value, say something like this. Or else you select a point from here to here, it will stretch. So normally people will manually stretch like this without using the tools given in the software. So you can try these things and see any questions, let me know about these five. And my objective is to do this tutorial with you. To do this tutorial, we have learned the slot tool, we have learned circles and arcs, but here you can find there are three slots. So shall we do the slot three times, draw this slot three times, or we can use a pattern tool. We can easily use a pattern tool and get the pattern of these shapes. I can't draw all these circles again and again. That is a waste of my time. So there are pattern tools available in SolidWorks. One pattern tool is called linear patterns. Other one is called circular patterns. So I'm going to discuss these tools now. So if we talk about the linear patterns first. So if I want to get several rectangles, one of the ways is we can copy the rectangles. Otherwise, we will use this linear sketch tools. We can select the entities here, select the line entities to pattern, and automatically this is my x direction, this is my y direction. X-axis is selected. You can change the direction from here also, and I'm changing the gap between the two entities, and you can apply dimensions between them, and I have two entities. So this is called a linear pattern. So in y direction I don't have anything. I have only one instance, that is this one. If I just apply two instances, if I increase the gap, this is my y direction pattern. So I don't want to copy these things again and again. You just use the linear pattern tool. I will just do it again. So if you start from a blank thing, you have to give the entities to pattern these entities. Even a single line I can pattern, no need to have the entire rectangle. And gap I can increase in x direction. Y direction also I will increase the instances. And gap also I will. Now, if I want to obtain an angle, we can give the angle with respect to x-axis. So now with respect to x-axis, this is 45 degrees, and this is still 90 degrees. So if you just type 135 degrees with respect to x-axis, this is my result. So 135 with respect to x-axis, this is x-axis, 135 degrees. So if you just give 90, it will be something like this. And if you give 0 here, it will be something like this. So always remember, horizontal side is x, vertical side is y. Shows here x and y, x direction is here. So we can dimension each one, and there at the bottom we'll find another tool called. Now if you press OK here, this is my result. Now you can make 3D extrusions, whatever the things you like. And if you want to edit this again, and if you want to change this pattern, you have to right click on this pattern. Then and there you have to right click and go to edit patterns. So there is no other way of editing this. You have to right click on the pattern and edit the pattern again. So when I come to editing, there is a tool at the bottom called instances to skip. So if you want, you can skip this. Unless if you don't like these two instances, you just skip them from the pattern. So this is my result. So I hope you understood. Right click on this and go to edit linear patterns. And at the bottom I find instances to skip. If you want everything back, just clear them and everything is back again. And if I come to extrusions now, contour selection will work. So you can select contours one by one. If they have same height, you can select all these things like this and do a quick pattern. 3D model easily you can get. So right click on this and go to edit. So I gave x direction, y direction, instances in x direction, angle in x direction, gap between y instances in y direction, number of instances in y direction, angle in y direction. You can have dimensions for the angles also, and entities to pattern these four lines, and instances to stick. So you do it and see any questions, let me know. Okay, so we will start. Now I will, in this tutorial, we don't need that linear patterns, we need circular patterns. So we will look at how the circular pattern works. So if I want to get a circular shape around the origin, I will apply the circular pattern to circular patterns. Entities to pattern are these things. So when you select the entities, automatically the center point is selected by the software. So this is the center point of the pattern, is the origin. So if you don't like the origin, there is a way we can delete this one and give another origin or another center point. So it says now 360 degrees full pattern. For instances, I can increase the instances, and it says dimension, radius, dimension, angular expense. So this will help us to make it fully defined easily. And the origin center point coordinates are given 0, 0. And now if I want, I can skip the instances here also. Otherwise, if I want, I can equal spacing is given, or else without equal spacing I can give a gap between two instances like this. So gap between the two rectangles are 30 degrees. If you want, you can change the direction like this also. So from this tool, it's easily we can change the direction. So I'm getting not a fully circular pattern halfway through. So we can just right click on this and go to edit circular patterns again. And if I want to have equal spacing, just put this button on, and it will be edit circular patterns, equal spacing, dimension, everything. So this is 360 degrees I want, 60. So this is 60 equal spacing. So this is how the circular pattern works. But if you want the pattern to be centered around a different point now, in this tutorial, the center point is here. Circle center is here. So this is the origin. This is the uh, circle center. So I have to pattern around this point, not from here. So if you have this kind of requirements, how can I do? So I want to pattern around a different point. So I will just do a rough sketch. Then there's a circle here. In this sketch, it says 70 for this origin, and this is 50 radius. So this is 50 radius, 50 diameter 100, and from here to here it's 70. So this is how it has been defined in this chapter 5 tutorial. 70. This is radius or diameter 100, and now if now we have to draw these circles. I can draw only one circle and pattern this. So it's better not to start from these unknown places. This is horizontal, this is horizontal, so easy to start from this one or this one. So we will start by drawing two circles. You don't want to worry about the arc shape initially because we can trim that later. So we can have two circles. One diameter is 10, other one diameter is one radius is 10, other one diameter is 10. So we will just draw two circles horizontally here. If you want, you can draw center lines, or this quadrant point are taken automatically. They have two circles here. So one has a diameter of 20, other has a diameter of 10. Now diameter 20, diameter 10. Then we can pattern these things without trim. So that's maybe the easiest trick. So I will apply circular patterns. This is the now when I click on the entities to pattern, you can see automatically it finds the origin, which is not my requirement. So this is the wrong point to pattern. So we need to delete this one and give this as the center point. So you can quickly change it to a different center point, and we have 6 altogether. So I hope you understood how this works. 6 circles. Then if I want, I can delete these unnecessary parts and draw the slot also. So we can use the trim tool now. So we will apply trim. Crosset one can be used. So these things I don't need. So this way we can obtain our shape. The center part is also not. So you can see lot of blue lines are appearing because I removed the circular shapes, circularity. So these things I didn't dimension. That's why you have lot of blue lines coming now. Yes,
So excuse me, I have a question.
yes.
How we define the center of that circular pattern?
When you draw something like this, if I want to get the circular pattern, I go here, automatically it goes to the origin. So we will delete this one and click on this one and try click on the center point. We don't need this one.
All right.
Now I have an issue here. I have lot of blue lines because I removed the part of the circle. So if you want, you can apply this automatic tool, or else we can ask the software to make this equal. Now this should be equal in radius, or this should be equal. So I will try to do a manual operation and try to make it the equal one. Now still it's black, still it's blue. So these circles should be blue, selected and all are equal. We'll try whether this is working. If this is not working still, we have to ask the software to fully define it. Otherwise it will take a lot of time from me. So yeah, we can ask the software to fully define the sketch. They will select this entity, this one, this one, this one, this one, this one. Select only the blue areas and do a calculation. Now he will try to put lot of relations for me, so I have a problem. So we better not get his help. We try this one and this one only. I selected only this line, so it's fully defined. So don't select all the things. Sometimes only one will be enough to make the fully defined sketch. So you can try this. We will meet after the break. Uh, this is chapter 5, tutorial 2. So we will continue this session after the break at 11 o'clock.